Hi guys, welcome to today's lesson video. Today we're going to continue our study in physics, specifically in motion. And today we're going to be talking about velocity and acceleration. Right now I want you to go ahead and get out your interactive notebook, something to write with, and a calculator. We're going to have a very similar format to the lesson we did last time on speed. We're going to go over some definitions and some vocabulary, and then we are going to practice calculating what we learned about. So go ahead and get those items out now if you haven't already. Okay, so today we're going to be talking more about motion. Okay, physics is all about how things move and why they move and what happens when they move. And so today, velocity and acceleration are there are two types of motion. Okay, so last time we learned about speed, and when you think of speed, you think of something in motion. When you think something is accelerating, you think it's in motion. And I'm not sure if you've heard the word velocity. It's very, very similar to the word speed. But when you think of velocity or a car's velocity or a motor's velocity, you think of motion. All of these things are different types of motion. Okay? So again, today we're going to be talking about velocity and acceleration. Let's start by reviewing what we already know. We know what speed is, and we've learned how to calculate it. Speed is the distance an object travels per unit of time. So speed encompasses two things, distance and time. In order to solve it, we actually do S equals D over T. So we divide the distance by the time it took to go that distance. And that's what speed is. Today, we're going to be learning two new vocabulary words. We're going to be learning about velocity and acceleration. Now, speed is very, very simple. Distance and time. Done. Velocity actually takes speed and adds on to it. So velocity and speed are often interchangeable. A lot of scientists use these words in change of each other, but they actually mean two different things. They're very, very similar, don't get me wrong, but there is a slight difference. Speed includes distance and time. That's it. Velocity is speed plus the direction. It includes the speed of an object and the direction in which that object is traveling or its motion. So velocity is kind of a step ahead above speed. It takes speed and says, I'm going to be a little bit more specific. And velocity measures the distance it takes and the time it takes to go a certain direction. So that's east, west, north, south, left, right. Different directions that explain where an object is moving. And then we have another new word, acceleration. And acceleration is actually, it encompasses velocity. So we have speed as our base word. Velocity is speed with direction. And then acceleration is when velocity changes. That's all acceleration is. It's when the velocity or the speed of something changes. And when the velocity of an object changes, the object is accelerating. Now, one thing that a lot of people think is acceleration means to speed up. It means to go faster. But acceleration also means to slow down. And a lot of people get confused. They don't understand how that could possibly be. We only typically use the word acceleration when we're speeding up or we're racing a car and we're going faster. But acceleration is just simply the change of speed. So if I'm running and then all of a sudden I stop, that's acceleration because my velocity changed. So it's not about going faster. It's about changing your speed, whether that's going faster or slower. So those are our two new vocabulary words today. Now, I've said that speed and velocity are very similar, and they definitely are. But what's the difference between the two? Well, let's talk about it. Speed measures the distance and time of an object. Okay, that's it. It measures how long it took an object to move a certain distance. Speed also measures how fast an object is using distance and time. Measurement does not include direction. So what I mean by that is speed only measures distance and time. It doesn't measure where you're going. It doesn't measure north, south, east, west, left, right, up, or down. It does not measure direction. However, velocity does. Velocity takes speed Okay, so if we know speed is distance and time, velocity measures speed or distance and time and direction. So it takes speed and says, I'm going to be a little bit more specific. And it tells us the direction an object is going. And an object's velocity depends on its direction. So I have a really interesting example for you guys. If you think about race cars going around on a speedway, they have constant speeds. Okay, if you think about two cars driving in the same direction around the same track at the same speed, okay, they have the same speed. The cars always have the same speed, okay? But through the turn, their velocity changes. Why does their velocity change? Because their direction changed. Now, when I talk about the speed of a car going around and around and around, the speed stays the absolute same. If they're going 60 miles an hour and they don't stop, they don't speed up, they don't slow down, it's 60 miles, the speed is constant. But even if they continue going 60 miles per hour, their velocity changes every time they change direction. So that's what's so crazy is a car can have the same speed for 20 minutes, but in that 20 minutes, it might change its direction, which means it's changing its velocity. And when things change velocity, whether it's speeding up or slowing down, that's what we call acceleration. Acceleration is the rate of change of velocity. So whenever we have a change of the velocity, we have a change of speed, distance, time, and direction. So when the velocity of an object changes, the object is actually accelerating. Remember that accelerating means just to change the velocity, to speed up or to slow down. So accelerating could mean that I don't move and then I start sprinting, or it could mean I start sprinting and I all of a sudden come to a stop. That is also accelerating. One big thing I want you to remember is acceleration occurs when an object changes its speed, direction, or both. This is the big takeaway from acceleration. Let me say that again. Acceleration occurs when an object changes its speed. Okay, so it speeds up, slows down, or it changes direction. It goes left or goes right, or both speed and direction have changed. Remember that speed plus direction equals velocity. So when I say it changes its speed or direction, it means velocity. When you see the word speed and direction, I want you to think velocity. Okay? Now, remember speed is distance and time. Okay? So that you could replace the word speed with distance and time. Here's direction, and whenever I have speed and direction, I have velocity. And then when I have a change in velocity, I have acceleration. So these words all build upon one another. So how exactly do we solve for an object's acceleration? We have a formula. This is how we calculate acceleration. So we have acceleration on this side. I really highly recommend you write out this entire equation. So we have acceleration on the left side, okay? And the unit is generally meters per second. And you'll also notice there is a squared here. I'm going to talk about that in a second. But this is the unit for acceleration. Now, could this be kilometers and this be minutes? Absolutely. It's going to be a distance and a time. A distance and a time. So it could be any type of unit for distance and any type of unit for time, but this is probably the most common example. And then we also have the squared here, which I'm going to explain in a second. So we have acceleration equals, and then we have a fraction right here. We have our fraction bar. As the numerator, we have change in velocity. So this is what is changing. The speed has changed. That number is going to be going up here. And that's represented by meters per second, just like speed. Remember, velocity and speed are very, 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 very similar, except speed does not measure direction. Velocity does measure direction, okay? But they both have distance per time, in this case, meters per second. And then on the bottom, we have just simple, good old time, and that's usually measured in seconds. It could be minutes, it could be hours, but in most cases, it's going to be in seconds. So you're probably wondering, Why is there a squared here? Why is there a exponent of 2? Well, I want you to take a look. Acceleration is the change in velocity divided by the time. So whatever the units are for velocity and time is what's going to be for acceleration, because all of this, these units equal this unit. So here we have meters, okay? And that is our only measure of distance in our fraction. And over here we have meters. We also have a second, okay? We have a measure of time, and we also have another measure of time. So we have 2 seconds. Because of that, we have an exponent of 2, okay? So we have that exponent because seconds is mentioned twice. We have 2 measurements of time, so we are going to go ahead and put an exponent. So your acceleration unit is always going to be a distance per unit time squared all the time. Now, you're also probably wondering, what is this right here? Well, I'm going to tell you. A equals acceleration, okay, pretty easy. T equals time, pretty easy. Change in velocity. When something changes, it means it went from something to something. So when we calculate our change in velocity, we're going to be calculating what the initial velocity was when we began to measure and what was the final velocity. And I'm not sure if you can see this, but this is an F right here. And this is a lowercase I. So this stands for final velocity. Okay, that F means final. Final velocity minus the initial velocity. So whatever velocity we ended with, we're going to subtract the initial velocity from that. And that's going to give us our change. So if I were to give you the equation 4 minus 2, what would you tell me the answer was? It would be 2. The difference between 4 and 2 is 2. And that's what we're finding here. We're finding the difference of the 2 velocities that we're measuring, and that's going to be our numerator. So let me break it down one more time. Acceleration is a change in velocity, okay? So that's what acceleration it measures. It measures when a speed has changed. It's either sped up or it's slowed down. But it's also including direction. So velocity is speed and direction. So we have acceleration equals a change in velocity, which is our final velocity minus our initial velocity, over time. And time is how long it took for the change to occur. So the time is measuring how long did it take for the velocity from the starting velocity to the ending velocity. And these two combined, when we divide time by the change in velocity, that gives us our acceleration. Now, we're going to go ahead and practice calculating acceleration. Okay, so we're going to go ahead and practice what we've learned about acceleration and how to solve for acceleration. So we're going to do 3 practice problems. Make sure to write down the gist. You don't have to write all of these words, but I want you to definitely show your work within your notes that you are going to submit for the lesson video in Canvas. So make sure that you not only include your notes, but you include all 3 of these practice problems in your notes. Otherwise, I will take off points. So let's go ahead and read the question. An airplane starts at rest and accelerates down the runway for 20 seconds. At the end of the runway, its velocity is 80 meters per second north. What is its acceleration? So right now, we need to dissect what are we looking for and what do we know? So the last question says, what is its acceleration? We don't know that. That's what it's asking us. So we don't know A right now. Okay, so that's our variable that we're solving for. And I also went ahead and wrote down the acceleration equation. A equals v2 minus v1 over t. v2, remember A is acceleration, t is time, v2 is the final velocity, and v1 is the initial velocity. You also could have put vf minus vi. Okay, these mean the same thing. This means the second velocity, this means the first velocity. VF means the final velocity, which is the second velocity, and VI, that I means the initial or the first one. okay? So it says an airplane starts at rest. So it is not moving. It does not have a velocity. It does not have a speed because it is at rest. So it starts, okay? So that's our key word. We know that that is its initial velocity. So V1, because that's its initial one, is at rest. So it is 0 meters per second. It is not moving at all. It is at rest. And it accelerates down the runway for 20 seconds. Okay, so based on that unit of seconds, we know that that is our t, 20 seconds. And then it says its velocity is 80 meters per second north. So that is our second velocity, or our V2. And it's 80 meters per second, but that's not it. It also tells us our direction. That's the difference between velocity and speed. Speed tells us the distance over time, whereas velocity tells us distance over time, and in which direction, and it tells us it's going north. So we're going to go ahead and add that to our unit. So now we have all of the missing pieces to solve. So now we're just going to plug and chug. So we are looking for acceleration. So what goes on top is V2, or the second velocity. In this case, it's 80 meters per second. And you don't have to write north every time, but I would like you to write the unit because it'll keep everything organized for you. And we have minus V1. And our V1 is 0 because it started at rest. So 0 meters per second. And that goes all over our time according to our formula. And our time is 20 seconds. Okay? So now we can go ahead and begin to solve. 80 minus 0 is 80 meters per second. We want to keep those units. And that's all over 20 seconds. 80 divided by 20 is 4. Now we need to figure out our unit. Remember that acceleration includes all the units of velocity and all the units of time. So we have meters per second, but we have another second. We have 2 seconds, so we're going to add our squared. However, we still need to include the direction it's going. And we know it's going north. So our acceleration, the airplane's acceleration is 4 meters per second squared north. And because that is our final answer, we are going to circle it. All right, let's move on to number 2. A skateboarder has an initial velocity of 3 meters per second west and comes to a stop in 2 seconds. What is the skateboarder's acceleration? So let's figure out what it's asking. It's asking us what the skateboarder's acceleration is. So that is our unknown variable. So A is unknown. And it says it starts with a skateboarder has an initial velocity. Okay, so our very first velocity is 3 meters per second west. And because it's velocity, it's not just going to include direction and time, it's also going to include distance and time. It's also going to include our direction. And it comes to a stop. So that means our second velocity is 0 because he went from 3 meters per second and then he stopped. So that's 0. So our second velocity is 0 meters per second. And then it tells us our time. He stops within 2 seconds. So our time is 2 seconds. We have all of our information and now we can apply it to the formula. So we have A equals, and we're going to plug in our V2. Our V2 is 0 meters per second minus our V1, and our V1 is 3 meters per second. And that goes all over our time, which is 2 seconds. Now we need to subtract stuff on the top. So we have, and there are no negatives in science, so we're not going to worry about a negative. We're just going to put, you can put negative if it really makes you feel better, okay? Remember, this is science, not math, so things work a little bit differently. But for the sake, we'll just go ahead and put the negative so you feel better. So we have negative 3 meters per second, because 0 minus 3 equals negative 3. And we have that all over 2 seconds. So right now we have an improper fraction. So we're going to go ahead and fix that. 2 goes into 3 one time with half of it left. So we have 1.5, technically a negative. And then our unit is going to be all of this combined. So we have meters per second. But we also have a second, which means we're going to have an exponent of 2, and it's moving in the direction of west. Now, you're probably wondering, what's up with the negative? I want you to think about the problem. It says he comes to a stop. So he goes from a velocity, and then he stops. So he's actually decreasing his acceleration, which is why we have that negative there, okay? And this is our final answer. All right, last one, and then you are going to work on your acceleration practice assignment. A cyclist starts at rest and accelerates for 20 seconds down the road. At the end of the road, his velocity is 40 meters per second south. What is his acceleration? So it's asking us what the acceleration is. Okay, so we don't know A. And it says he starts at rest. So our beginning speed is 0. So V1 equals 0 meters per second. And he accelerates for 20 seconds. So that's our time. He accelerated in 20 seconds down the road. And at the end of the road, his velocity, so his final velocity is 40 meters per second. So our V2 is 40 meters per second, and also tells us our direction, which is south. Okay, so now we have all of the missing pieces, and we can go ahead and put them into the formula. So we don't know A, but we're going to plug in our V2. Our V2 is 40 meters per second. Minus our initial velocity, and because he was at rest, his initial velocity is 0. And that's going to go all over our time, which is 20 seconds. Now we can go ahead and do the math. 40 minus 0 is 40 meters per second on the top and 20 seconds on the bottom. And then from there, A equals 40 divided by 20 is 2. And then we need our unit. Remember, acceleration is going to include all of the units in the problem. So we have meters per second. But because we have 2 seconds involved, we have 2 sets of time involved, we're going to add a square because there's 2 of them. And we need to include our direction, which is south in this problem. And then we circle our final answer. Okay? So I hope those made sense. Please reach out if you have any questions about these. And you guys are going to go ahead and get started on your second assignment for the day, and you're going to be practicing these. Bye, guys. Have a great day.